Students, we are looking at lesson 9.4. I have sent you some handouts for this lesson, some things that I've scanned from my notes. I'm going to make some corrections as we go along, and I'm also going to send you some corrected scans. The title of this lesson is Symmetry, Increasing and Decreasing Functions. Sort of like it's got two parts. Most of you have a good idea of what symmetry means. If you're looking at the graph that I have drawn here, you know that this would be symmetric to the x-axis. The second one would be symmetric to the y-axis. You know that if you had this drawn on a sheet of paper and you folded it on the y-axis, that both sides of this would match. If you folded this one on the x-axis, both sides of this would match. That's how you tell symmetry, by just looking. Example 3. If you look at this graph and you think, oh, if I folded that on the y-axis, both sides would match. So I know that it is symmetric to the y-axis. If I folded it on the x-axis, both sides would match. I know that it is also symmetric to the x-axis. If I made two paper folds, if I folded it on the y and then again down on the x, it would also match. So that tells me that it is also symmetric to the origin. So if you make two paper folds and make these sides match up, it's symmetric to the origin. For 99% of the problems you're going to work, you're going to be able to graph them with your graphing calculator, look at the graph, answer the question. There's maybe one where you cannot put it in your calculator. If you cannot put it in your calculator, then these are the rules that you follow in order to make that determination. If you want to find if it's symmetric to x, replace y with negative y. And if you get the equation you started with, that's telling you that would be symmetric to x. And likewise for y, replace x with negative x. If you get the equation you started with, symmetric to y. If you replace both x with negative x and y with negative y and get what you started with, it would be symmetric to the origin. Page 2 on the handout that I had emailed you earlier showed using the rules to make those determinations of whether or not the equations were the graph's symmetry. But we don't want to do that. We want to do this with our calculators. So number 1A, determine symmetry by looking at the graph if possible. Y equals x squared plus 4. We're going to graph this one, and then after that, we won't graph most of them. I have the graphs already drawn for you. But go zoom, go down here to standard so that your screen looks like mine, your window looks just like mine. Go to y equals. If you have any equations in there, clear them out. Put this x squared plus 4 in there. Graph. You're looking at the graph, and it's easy to tell that that is symmetric to the y-axis. B. What is this symmetric to? 2x plus y equals 4. Before I put that in my calculator, I got to solve for y. When I do that, I have y equals negative 2x plus 4. That line looks like this. Well, there's no way that I can fold this paper and make any sides of this match up, so it's not symmetric to anything. If I folded it on x, nothing matches. Folded on y, nothing matches. No symmetry. C. X equals the absolute value of y. I can't put that in my calculator. I have an absolute value function on there, but all of the equations I put in that calculator had to be y equals. None of them are, there's no way to put x equals that I know of. So I'm going to check it out with the rules. When I replace y with negative y, I get the exact same thing that I started with. So I know that x equals absolute value of negative y is the same thing as x equals absolute value of y. Therefore, this is symmetric to the x-axis. Very few that you will have to use the rules on, but that one you do. Example 2. I want to know what 3x equals 5y is symmetric to. Divide by 3, put it in your calculator. It looks like this. If it goes through the origin, there's a possibility that it might be symmetric to the origin. If it's a line especially, so you're going to say, I know it's not symmetric to x, not symmetric to y, but if I were to fold this on the y-axis and then again down on the x-axis, this line would be right on top of this one. That makes it symmetric to the origin. B, divide both sides by 2, put it in your calculator. You look at this graph, easy to tell, symmetric to the y-axis. C, y squared equals 4 minus x squared. If I want to graph that, I have to solve for y. I have y equals plus or minus 4 minus x squared. That's actually two equations. Put them in your calculator. y1 equals the square root of 4 minus x squared. y2 equals the opposite of 4 minus x squared. Let's put that in our calculator so you're sure you know how. You have the square root of 4 minus x squared for y1. Use that little white negative key down at the bottom. Second square root of 4 minus x squared for that second equation. Graph. You see the graph that I've drawn on this paper. We know that that is definitely symmetric to the x-axis, the y-axis, and the origin. Got her done.